Hello everyone! Today's case is in a sense universal because firstly it contains practical examples of the application of consumer-driven pricing methods used in the activities of the project's working group at the earlier stages of development, pre-project milestones and milestones of the development of design engineering documentation. And secondly, it serves as a conditional practical supplement to issue number 15, product marketing concept in the context of design to cost methodology, in which a table of pricing methods has already been considered, containing the names of all methods which will be applied today. Thirdly, it's an auxiliary material for students in a course training work of the discipline design to cost management methodology based on value analysis, which, as I mentioned earlier, is included in the curriculum of the Department of Industrial Management of Mises University since the fall of 2025. So, if we go into details, then today's case is nothing more than examples of the application of marketing, parametric and standard methods of product pricing at the early milestones of the product in the context of the application of design to cost management methodology. The object of pricing in this case will be already painfully familiar geometry signboard 25 drawn, accordingly to the link between pricing methods, in some of which we use the retail sale price, and in others direct cost calculation items, as in practical case in case number 2, or will be the margin which to some extent, but quite acceptable, simplifies the real picture, replacing the transition from direct cost to selling price of a single copy in a retail network. In fact, the value of marginal profitability in this case contains maintenance and operational costs, workshop costs, production of non-production overheads, excise tax or similar taxes, as well the profit of the manufacturer, of the margin of the dealer or retail chain. However, I suggest that we do not delve too deeply into the subject of consideration as part of the introductory remarks, and conclude by listing a number of simplification of the pricing methods table discussed in issue number 15, which consists in the fact that this issue doesn't address setting pricing goals, the first, the second, determining the pricing strategy and setting the selling price. The amount of marginal profitability is considered fixed for simplification of thought within the framework of the strategy. It can change throughout the life cycle of the products on the market. The third, marketing research data, external or internal. And the fourth, general advantages and disadvantages of groups of pricing methods. The particular disadvantages of each method will be considered in the framework of the description of calculation example. Part 1. Definition and standard pricing concept. As part of the preparation of the next issue by analogy with the preparation of a scientific article, I try to study the theory and modern practical approaches used in the field of review to the best of ability and availability of free time, especially for areas in which I do not have sufficient practical experience. At the moment, I can say that a very significant amount of such work has been done in preparation for issue number 15, which deals with the applicability of value analysis tools in marketing. The issue of pricing, in turn, is somewhat more familiar to me than practical marketing, since I have been a cost engineer for some time. For the classical sense of word, I have some experience in analyzing various forms of presentation and justification of products' prices, both from the customer and from the supplier, moreover both domestic representatives of these social groups of individuals and foreigners. Most of my experience is related to the pilot production and related technologies, since I specialize in early milestones of a project. However, I also have some experience in switching from prototypes to mass production in terms of modifying calculations at the time of this transition. I also have. Nevertheless, I would like to point out the following. In most sources of information, for example, on the websites of companies offering analytical services, as well as textbooks and manuals on pricing, three main sections of pricing are considered. First, pricing factors, second, pricing stages, and third, pricing methods. Pricing stages, in turn, they are usually divided into setting pricing goals, increasing profits, customer retention, survival, and etc. The second, analyzing pricing factors, determining demand, analyzing competitors' prices, etc. Choosing the pricing method, and the last, defining the pricing strategy and setting the selling price. As you can see, this list doesn't include, at least explicitly, such an inconspicuous stage of quotation marks as the formation of initial data for pricing. I suppose the authors simply forget to mention that among such purely marketing raw data for pricing contained in the paragraph analysis of pricing factors such as determination of demand, competitor price analysis, and etc., the evaluation of which is carried out within the framework of marketing research, independent or purchased, may accidentally include such sub-items such as formation of data on the design engineering structure of competitors' products, or benchmarking, formation of data of the cost structure of competitors' products, formation of data of the list of competitors' options, and etc. The second explanation for the lack of mention of the listed initial data for pricing is the author have a somewhat idealized opinion about the world around them, but the world, as practice shows, is generally far from ideal, and it contains industrial espionage and specialized benchmarking software, see Atomark 1 and Analyx. Yes, and calculation of varying degrees of detail acquired by accident can sometimes end up to the hands of competitors. In short, we will not follow the standard general presentation of the issue of initial data for pricing, and will focus on it in a little more detail. Generally speaking, the concept of raw data for pricing is also quite abstract and practically doesn't reflect the practical essence of the raw data used. In fact, the missing factors listed above, or in other words, initial data are actually needed not only for direct pricing, but primarily for choosing a pricing method. Therefore, in the context of further discussion, we will refer to them as initial data for choosing a pricing method, i.e., from the point of view of the full range of their applied use. As we mentioned above, the initial data for pricing can be roughly divided into marketing or demand determination, competitor price analysis, etc., and technical and economic. Formation of data of the design engineering structure of competitors' products, or benchmarking, formation of data of the cost structure of competitors' products, formation of the data on the list of competitors' options, etc. In fact, we are talking about a list of initial data necessary for the formation of calculations of product components. The first group, in accordance with the list of simplifications agreed upon above, is not being considered by us, since the data listed in it has already been partly reviewed in issue number 15, and for their full consideration, it's necessary to conduct actual marketing research for a specific product, conduct or order, which personally in my plans for not included today. The second group is exactly what the working group is primarily interested in as part of the pricing activities, the early milestones of the project, since it's during this period that there's maximum shortage of initial data for analysis. In general, in order to set the price correctly, the following factors should be considered, as shown on the slide. First, direct product cost. Second, positioning, i.e. segment definition, luxury, mass market, or economy. Third, the competition and competitors' prices, presence of monopoly or competitive environment. And the last, fourth, marketing products life cycle. With regard to the marketing life cycle, we're actually talking about the duration of the stages of the marketing life cycle and other indicators that we have already discussed in issue number 15, namely such indicators as the integral relative indicator, sales plus profit, and etc. Pricing strategies were also discussed in the pricing methods table. In today's issue, we are not considering. The economic state of the region, for example, during periods of financial crisis, consumers and price-sensitive and prefer economy segment and mass market goods. The next, legal norms, for example, the existence of a legally limited price threshold for a number of socially significant products, etc. And the third, consumer perception of the price. Excessively low cost may cause doubt, and a consumer excessively high scare away. The status of consideration of non-consideration of these common factors is indicated in the column status within the framework of the case as part of our release today. The relationship between the factors and pricing stages shown on the previous slide is, in my opinion, quite obvious. The amount of direct product cost in the case of mechanical engineering depends on technical and economic parameters of developed products. In other words, the amount of available technical and economic input data is extremely critical for calculating direct costs at early milestones. It should be noted that for modern machine building products, there's a tendency for direct costs to become less dependent on technical and economic parameters due to the rising cost for software and conventional electronic components compared with the conventional mechanical parts of the product. Taking into account the above, the next step would be to consider the stage of formation and analysis of technical and economic initial data. However, there is no actual need for this, since the process of collecting initial data for reverse engineering is described in sufficient detail in the first part of practical case number 2 of the cost engineering training course, and generally describes all the stages of collecting the initial data needed at the early milestones of the project. We are talking about data on the design engineering structure of competitors' products or benchmarking, and data on the cost structure of competitors' products, and data on the list of competitors' options. Thus, within the framework of the design-to-cost methodology based on the value analysis, the process of generating initial data has already been standardized, since it is standard forms in the tabular editor that can be used, which were demonstrated in the case number 2. I don't see much point in forming a separate block of initial data for analysis, containing only data for completing calculations, since the calculations themselves, which will be considered in today's issue, are these standard forms for collecting initial data. In terms of describing the specific criteria for choosing a pricing methodology, the sequence of the actions in the first approximation was described on the slide, pricing stages. From what can be added to this sequence in order to somehow concretize it, I would highlight the following. From the point of view of marketing, the chosen strategy should correspond to the value of the integral relative indicator, sales plus profit, respectively, since at the stages of pre-project and the stage of the project design engineering documentation, the value of this indicator is 0. Working group as a pricing entity, not burdened with the need to take into account the marketing factors listed above, has relative freedom in choosing pricing methods, which is limited to 2 factors. The first factor is pricing strategy, and the second factor is the availability of initial technical and economic data for the formation of calculations. For subsequent milestones of the project, the choice of pricing methodology is carried out within a more stringent framework and should take into account such factors as and the first, known zero value of the integral relative indicator, sales plus profit. In our case, it changes first from 0.2 to 1 and decreases about to high level 0.5 closer to the end of the marketing cycle. And the second factor is the accounting policy of the production site, where productions will be carried out. For example, if the accounting policy uses either a custom cost accounting system or the direct costing system, pricing will obviously be closer to the concept to cost plus. In the case of the using the to-cost pricing methodology, obviously more appropriate this will be sites in the accounting policy of which systems are prescribed that are close to either the regulatory cost accounting or the standard cost system. So next we will look at various pricing mechanisms using the example of the metamorphosis of the conditional basic product calculation of the basic product CBD for the signboard 25 drawn. The metamorphosis in this case will consist in modifying the basic calculation presented on the screen depending on the pricing methodology used and the milestones of the project. The purpose of this approach is to model the maximum possible number of calculation options for the product and the corresponding initial data options for their formation, which a cost engineer may encounter and internal milestones of the project. Let's start with terminology, because if this isn't done, there may be some confusion. So the term basic in this case means that all other calculations formed in accordance with the pricing methods listed above will be conditional derivatives of the basic product calculation, i.e. they actually correspond to it in terms of basic indicators such as the selling price, the amount of direct costs, and etc., not corresponding to it in terms in the form of information presentation and the list of necessary initial data. The phrase compliance with basic indicators of the basic calculation means in particular the following. An example of the application of the marketing pricing method will be discussed in more detail below. However, if we pay attention to the summary table of stage 1 for this period, we can see the full correspondence of the indicators total cost, selling price, retail price, and profitability with the basic product calculation. However, for example, the indicator profit per unit in marketing, it's customary to calculate the difference between the total cost and the selling price, and it's $35, whereas the basic design engineering calculation, the value of the profit parameter is fixed, and according to the business plan, it amounts to 8.8% of the selling price without VAT, i.e. $31.6. Thus, the difference in the degree of abstraction of consideration, the difference in the structure of the calculation, the conditional traditions of naming and calculation methods for different areas of professional activity lead to minor deviation in individual intermediate indicators, but the basic indicators remain similar in magnitude. Let's return to the terminology used in the concept of basic project calculation, named the term project, which in this case means that the calculation describes a change in the most structure of the product at the milestones of the project design engineer documentation in accordance with the GOST 2.103, see columns names, and not because that is being used as part of the project. Having finished with the terminology, let's look at the structure of the concept of filling the basic product calculation. So the calculation consists of two parts. The upper part contained end-to-end design engineering data, namely the structural model and prices of purchased products for the signboard 25 drone, which we reviewed in the issue drone review using the value analysis method, WOOP 2.5 inches. And the second, the lower part, contains the standard cost item for the mass produced product. In terms of the initial data for the formation of the basic project calculation, the following can be noted. As a pre-project milestone, we have access to the customer's technical requirements data from the business plan, the prices of purchased products, either received to the response to verify or generated independently, market research data, if they were conducted, production and overhead costs set by the cost engineer and the first approximation, and margin profitability indicator calculated based on the target retail sales price taken from the business plan. The dealer's margin is set at 7%, depending on this industry and the external factors. This indicator may vary. At the milestone of the technical proposal, the basic calculation is somewhat clarified. In particular, the cost of materials used in production and assembly and not related to purchased products appears in the first approximation. The possibility of clarifying the calculation at this stage is directly related to the appearance of the first approximation of a set of design engineering documentation for milestone technical proposal. As the milestones of the preliminary and technical design engineering, the basic product calculation is further refined and gradually approximated to the format of the actual production calculation, which will be formed at subsequent milestones of the project, i.e. of the start of mass production of the product and approval of corresponding serial design engineering documentation. In particular, we see an increase in the level of detail in the section material costs, the appearance of values of the items, transportation and procurement costs, general factory costs, other production costs, etc. In addition, we are moving away from the conditional rough indicator marginal profitability, and we are using the standard indicator profitability, calculated on the basis of the indicator total cost and profit. In terms of the project milestone under consideration, as in previous issues, we will consider 4 early milestones of the project, corresponding to the stages of design engineering development according the GOST 2.103, namely milestones of the pre-project, technical proposal, preliminary design, and technical design engineering. In issue number 15, I didn't provide such a table indicating only the marketing parameter cost and market methods can be used simultaneously, or rather, individual indicators of market methods, such as the target selling price of a product, can be used as part of parametric and marketing methods at early milestones of the project. In today's issue, this table is presented for the consumer-drawn object we are considering, so it should be borne in mind that this applicability may change not only when considering other branches of engineering, but even if we move from one drone segment to another, for example, to the segment of combat or special drones. So, let's proceed directly to the consideration of pricing methods, which are shown on the slides currently displayed on the screen. First, parametric methods. 1.1 The aggregate methods, BOM or bill of material method. The first group is parametric methods, a general description of which has already been given above. I put the aggregate methods, or bill of material method, as the first of parametric methods, but not only because it's the most common method used within the framework of the conditional classic approach to cost engineering. The description of the content, advantages and disadvantages of which was partly devoted to issue number 2 of the cost engineering training course. In practice, I have dealt with various types of calculation which can be attributed to those generated using the aggregate pricing method at various milestones of the project. The mention of milestones is critical in this case, since the current milestone significantly affects the appearance of the calculation when using the aggregate method. Similar calculations were called either just the cost structure of the product or the BOM, or the bill of material. I have already mentioned in previous issues that the abbreviation BOM has become popular in many industries, where its original appeared I cannot say, but I personally first encountered in the automotive industry. I also mentioned earlier that many people refer to various types of calculations as BOM. According to the degree of detail of the product review, there are 2 types of BOM, formed mainly manually and formed mainly on the basis of the uploading from the ERP system. And the format, as we will see below, can be in this case. For listeners who can hardly imagine the difference between the design engineering structure of product at the milestones we are considering and the milestones of serial design documentation, I will simply say that you can assume that no one will provide you with a normal design engineering structure at these milestones, and therefore the design stuff in a ERP system, it will be also a pitfall sign. At best, the ERP will have a product under development which meets in units and systems, and at worst, some kind of assembly of new units and system mixed with units and systems of previous generation products. This sentimental digression was made in order to explain the reason for considering 2 types of aggregate calculation of 2 types of BOM on the slide. BOM at the stage of pre-design and pre-design engineering documentation, and the BOM on the stage of serial design engineering documentation. In my practice, I have encountered both separate BOM. This case will not be considered in this case by us, and a combined BOM for a pre-project, project, and serial design engineering documentation. And combined and uncombined in this case means that there are differences in the format. i.e. a different set of columns, their names and other parameters. Looking ahead, I will say that within the framework of the design-to-cost methodology based on the value analysis, the BOM is firstly modular and secondly combined or universal, i.e. its form is uniform, starting for the pre-design milestone to the start of mass production. Just depending on the milestone, it's allowed to be filled out individual columns or entire models or BOM blocks. The advantage of the combined option is that all the milestone data is presented within a single file. The disadvantage of this approach so occur, namely the cumbersomeness of the file both horizontally, number of columns, and vertically, number of rows. If we simplify the description of these two types of BOM somewhat, then we can use the following informal definitions. BOM is a stage of pre-design and project. Is an electronic table fully unautomated, manual formation and updating, table containing three types of structural components, the main units and systems of the product. The largest components of the main units and systems, and the third, the smaller components, fasteners, parts, assembly materials combined under single destination, one item or BOM line, for example, fasteners or connectors. The main criteria for inclusion in the BOM as a stage of pre-design and design engineering documentation are: first, the presence of a top level in the technical assignment in the current design engineering structure, and the second, availability of a commercial offer for this component. BOM at the stage of serial design engineering documentation is a spreadsheet based on a conditional automated block, i.e. not formed manually, based on unloading the product composition from an ERP or PDM system, depending on the design or economic characteristics of the product components you are interested in, i.e. it has a higher degree of automation and more low labor intensity compared to BOM at the stage of the pre-design and product design engineering documentation. In fact, BOM at the stage of serial design engineering documentation is a cultivated unloading, i.e. manually adjusted using a tabular editor to the format set in the project. BOM at the stage of serial design engineering documentation can be considered conditional development of BOM in the stage of pre-design and project design engineering documentation, especially since within the framework of the design-to-cost methodology based on the value analysis, we are talking about the complete identity of the standard form of BOM implemented in modular format, i.e. the two types of BOM are considered differ, in fact, on the degree of complexity fitting as well as the level of detail of the product structure. Slides with a table containing a complete list of difference in the degree of detail and filling out the standard from the two types of BOM as well as their difference from the basic design calculation are currently on the screen. In principle, if you introduce a conditional standard BOM module in ERP or PDM, which will formalize the BOM form in force at the enterprise, then the BOM can be uploaded, really made, i.e. in a form, but doesn't require manual improvements. In principle, I came across the BOM that by all indicators were already automated, i.e. they had the conditional facelessness inherent in standard forms, and there were no errors inherent in humans. Accordingly, the first columns of the basic project CBD or cost breakdown is nothing more than the basic design engineering calculation, the concept of which was introduced by us at the beginning of today's case, and which is something quite close to the standard calculation form to the aggregate methods, with the exception of some differences, which we'll now consider in a little more detail. The criteria for comparing the basic project and two types of aggregate calculation, two types of BOM, can be attributed. Criterion 1. Separation of responsibility for filling in the BOM profile blocks or modularity. Generally speaking, it would be more correct to compare the block BOM which corresponds to the concept of design-to-cost management methodology based on the value analysis. In terms of sharing responsibility for filling blocks with the conditional classic BOM used in the framework of the classical approach of cost engineering, which was described by us rather than the basic project calculation formed by the cost engineer as part of the issue number 2 of the course, cost engineering everything would be fine. But there are no pronounced blocks in the classical BOM, and accordingly, there can be no division of responsibility. In short, the classical BOM is led to a cost engineer, and no one except a cost engineer with all the advantages or disadvantages that follow from this. In general, the listener just needs to remember that in classical cost engineering, the BOM is conditionally monopolized within the framework of the design-to-cost concept. It's divided into blocks, the responsibility for filling which is borne by a specialized specialist. Data on deviation from the target values of direct costs from all blocks are summarized in the block of cost engineering attributes for signboard 25, and this creates the illusion that the cost engineer in this case remains on the vault, i.e. Retains his role as curator, but this is not entirely true, because the final user of BOM and the supervisor of the process of filling it out within the framework of design-to-cost management concept is the project manager, which will be mentioned below, and this issue will be discussed in detail in issue number 20, Project Management in the Context of Design-to-Cost Methodology. Criterion 2. Conditional and non-automated or manual generation and updating. By manual formation and updating of the form at the stage of the pre-project and the project design engineering documentation, it means that at the milestones corresponding to the stages of pre-project and project design engineering documentation, the cost engineer mainly manually enters data in a standard form formed in a tabular editor. Typical sources for filling in the BOM at this stage are technical assignment, drawings, 3D models, explanatory notes, the milestones of the project, technical specification, technical assignment from suppliers, and etc. Criterion 3. Conditional automated general update in ERP or PDM uploads. As I mentioned above, in most cases we are not talking about complete automation, but what we mean by automated BOM generation and updating is that the milestones corresponding to the serial design engineering documentation stage, the cost engineer still operates with the file in a tabular editor format, but automatically generates, uploads most of it. In other words, the complexity of creating a serial BOM is reduced compared to the BOM for the pre-project milestones and the project design engineering documentation, while increasing the level of detail, i.e. in other words, increasing the number of rows and field columns. In addition, work with initial data is minimized, such as technical assignments, drawings, 3D models, explanatory notes to the project milestones, technical assignment from suppliers, and etc. Since all initial data is processed by departments responsible for updating data in ERP and PDM system. Criterion 4. Specifying the make-buy status for the component. Regarding the need to specify the make-buy status in the BOM, it seems to me that no comments are required. Setting the status is desirable in both cases, since an understanding of whether a product is purchased or not generally appears already as the earliest milestones of the project. Criterion 5. Indication or approved target direct costs for the component, as well as target direct costs calculated using various pricing methods. In most cases, we are talking about the target value of direct costs for make-type components and the target price for buy-type components, since almost no one provides reliable calculation for purchased products, and this applies to both domestic and foreign companies. More precisely, the situation is as follows. Calculation adjusted to the price in the labor market represent everything. Calculation containing actual marginality represent no one. As a rule, the target price is set only for milestones of mass production according to the corresponding serial design engineering documentation. Target estimates, prices for the pre-project and milestones of the project design engineering documentation are not set because they are, to put it in mildly, difficult to calculate in general and against the background of the number of prototypes and other one-time costs. The value can often be neglected. The actual implementation consists in creating two columns of the BOM for serial design engineering documentation file, target direct cost price and methodology for estimating target direct cost price. Within the framework of the non-automated BOM for projects design engineering documentation, the two mentioned columns can be given for reference. As in done in our case, see an asterisk for criterion number 16 on the slide. In the pre-project and milestones corresponding to the development of the project design engineering documentation, we usually do not have target prices for component, but only target price for the product formed, for example, on the basis of marketing research within the framework of the two cost pricing concept. Now we are talking about the case with a consumer for UAV. For example, Signboard 25 is a simple drone, and UAV it's with Googles and radio. One of the tasks of the cost engineering division as a part of the working group is precisely the conditional distribution of total target price by components. The intermediate stage of which is firstly the determination of target direct cost based on the given marginal profitability, and secondly the application of value analysis techniques, in particular the construction of RQS diagrams. In this case, it's missing S parameter because it's a desired parameter, and setting target direct cost for individual components in accordance with the result obtained, distribution of both significance and quality of execution. Criterion 6. Indication of the availability of a calculation of the direct cost price of internal production purchase part, option make, and external supplier, option buy, performed by the expert assessment method. We are talking about calculations generated by expert assessment methods, and we can by expert assessment methods and obtained either from supplier, from own internal production. In my calculation, I proceed from the fact that such calculations are not reliable a priori, also that they undoubtedly have different degrees of reliability. Therefore, I personally perceive their conditional presence in the BOM as nothing more than a guideline that sooner or later must be clarified. See the star or asterisk indicating the value of reference. Note that the degree of the detail in depth of the expert calculation mentioned is put in mildly lower, for example, than the planned calculation in the ERP system, which take into account change in the exchange rates and inflation. Criterion 7. Indication of the availability of the actual calculation and the direct cost price of the internal production purchase part, option make, or an internal supplier, option buy. Regarding the presence or absence of the actual calculation from the frequently used concept of reliability level, I have repeatedly expressed in my opinion, so I will not comment in detail, noting only that for me personally, only the production shop calculation used in productions is reliable. Once again, I would like to emphasize that no calculations received from the supplier, other than this confirmed by audit or timekeeping, that can be considered an actual calculation, and the only actual document on the absence of an actual calculation should be considered a labor contract Criterion 8. Indication of the deviation of the current export direct cost price values from the target values. The degree of reliability of deviations of export calculation using export assessment techniques, direct cost prices from the target values, is a function of the degree of reliability of export calculations that were considered in the part of the consideration of the previous criterion. Criterion 9. Indication of the deviation of the actual according to the labor code prices value from the target values. Deviation of the actual direct cost prices indicated in the technical commercial proposal from the target values can be visualized in BOM in both absolute and relative percentage terms. Criterion 10. Indication of the potential for reducing direct cost or price of a component. The cost reduction potential can be calculated by forming a cost reduction action plan, the proof of which is usually individual for each design engineering bureau. One of the options for forming activities for the plan, the use of factor research method, which was devoted to issue number 9 of the training course. The potential for cost reduction can be highlighted by visualization tools and shown in the context of the target and actual prices of the component both in the most basic BOM field as well as the additional analytical reports. Criterion 11. Specifying the full structure of the retail selling price of the product. The final selling price of a product and its structure are usually absent from the main BOM field for the reason that they are not within the framework of the BOM, the main object of analysis. The main object of the analysis within the framework of the BOM is direct costs of the products, components, and their deviation from the target values of direct costs, which in turn consist of purchase parts and products of their own production, if the latter is available. However, in practice, of course, there is always a separate field of a separate type where the selling price is calculated for reference based on the amount of direct cost calculated in the BOM. In this issue, we will deviate from the standard BOM view. See the asterisk for criterion number 1 on the slide. We will not hide the sales price calculation performed within the framework of the basic project calculation on a separate tab. Since the structure of the signboard 25 drawn, this question generally occupies only 16 lines. Of course, there are no problem with placement, not by chance, but because we choose a relatively small analysis object for analysis, which conditionally corresponds to a small system or unit, for example, of automobile, i.e. even the case of formation of automated bill of material for the descent bike, motorcycle, or car, we also would not have left the main field even for simplified calculation for the selling price. Criterion 12. The presence of top-level components, main units or systems, the description of the product structure. Everything is pretty transparent here for almost a mechanical engineering product. As a first approximation, we can identify from 10 to 20 basic systems and assemblies in accordance with the content of the section Technical Requirements of the Technical Assignment according to GOST 15016 or similar foreign regulatory documentation, which we reviewed in issue number 10 of the training course. Examples of such top-level units or systems, for example, for a car, power plant, chassis, black body attachments, interior elements, exterior elements, security systems, climate control systems, or HVAC. We will look at the breakdown for the drone as part of the review of two types of BOM just below. Criteria 13. The presence of individual mid-level components, so the description of the product structure, simple assembly units, assemblies, electronic components, etc. The criteria for assigning a component to the middle level are the entire of the form of an upper-level assembly unit into components aggregates or upper-level systems mentioned above. The absence of a separate technical assignment per component. As a rule, a separate technical assignment is formed for component related to the largest aggregate systems of the project. For example, a car is, for example, an exhaust system, interior mirrors, glazing, a driver's passive safety system, a bumper, headlights, lantern, etc. The requirements for all listed components are listed in the general upper levels technical specification for the car. Criterion 14. The presence of individual lower level components in the description of a product, structure, parts, fasteners, or various types, standard products. The presence of lower level components in the structure means, first of all, the presence of hardware and so on. Standard products either in the form of single combined item, BOM of the pre-design stage and the product design engineering documentation, or in the form of actual list of term items. By analogy with the design engineering specification, BOM for the serial design engineering documentation stage. As a rule, correct hardware data appears on at milestones corresponding to the development of a serial design engineering documentation. Criterion 15. Decomposition, separate consideration of the main units systems. In fact, when we talk about an automated or decomposed BOM at the stage of pre-design and product design engineering, we are talking about a group of files or tabs in a single file or tabular editor, each of which is a BOM for a separate unit or system. Each of the options has its advantages and disadvantages. In the case of individual files, they can be assigned to the responsible cost engineer in the direction which saves us from all the charms or simultaneous work of several people in one tabular editor file, or shared access to the tabular editor file in which the decomposed BOM is located on separate tabs. On the other hand, with separate files, sometimes there is a problem with the unification, since a cost engineer may turn out to be, for example, an individualist anarchist and add a couple of columns by changing a single structure, which will cause a problem when consolidating information from the BOM for different systems when forming a consolidated BOM. Thus, sooner or later, there comes a time when the manual undecomposed BOM one file tab increases to such a volume that it first goes to the state of manual decomposed BOM or several files tab, and then it must go into the state of automated BOM, decomposed or undecomposed, depends on the degree of complexity of the product. As part of the cost engineering course, we draw the boundary of the second of these crossings at the end of the technical proposal milestone. This conditional transition point is generally important, including from the point of view of the conventional division of cost engineers into two groups: cost engineers of early milestones and cost engineers of serial milestones. The required skills of these two groups of cost engineers are quite different, and we will discuss them below, so I'll just say that when the conditional cost engineers of early milestones sees that it's time to cite letters O, O1, etc., it's time to think about your future and update your resume or CV, especially if the company doesn't plan to open new projects. Criterion 16. Joint separate descriptions of the list of design model range. In terms of non-automated descriptions of the list of design engineering versions, model range, or assortment, where use of marketing terminology within either a single file tab or separate file tabs, everything is relatively simple. A column is added to the table in which its applicability for each component is indicated. The obvious disadvantage of this approach for manual non-automated BOM is the duplication of identical components with different applicability. Nevertheless, given that the BOM structure isn't yet cumbersome, several tens or hundreds of lines at the milestone of the pre-project or technical proposal, such an approach is acceptable. As the non-automated BOM becomes more complex and the number of rows increases, the composed BOM are applied. Criterion 17. Specifying the format, design engineer attributes of components, numbers of drawing, 3D models, names, type of part, essay purchased part, etc. The group numbers in the number of drawings of 3D models of the main units and systems in certain industries are regulated, in some they are not, and correspond to the United System of Design Documentation. In terms of the system of business process adopted a particular design bureau, in general, the top-level numbers can be entered immediately. The numbers of the subassemblies are already at the stage of serial production. Criterion 18. Specifying quantitative design attributes. The ability to specify quantitative characteristics, i.e. the number of parts in the assembly unit or in the product as a whole, directly depends on the stage of design engineering documentation development. Obviously, the number of engines and propellers will not change for the quadcopter. However, the number of individual fuselage elements, brackets, fasteners, harnesses, etc. as a rule will change during the design process. Criterion 19. Specifying quality design engineering attributes. The ability to specify qualitative characteristics such as weight, dimension, material, manufacturing process, and etc., as in the case of quantitative characteristics, directly depends on the stage of design engineering documentation development. To a first approximation, some information can be taken from the analog table, the structural model, and the weight list, as well as from the list of non-technical characteristics of the purchased products. Criterion 20. Specifying the numbers of goods used in the buyer's management system. In terms of specifying the number of inventory items or inventory item, in different organizations this number is called differently, i.e. the number of according to which records are kept the procurement system. It can be said that the presence in the BOM. Firstly, it can be implemented at the best of the milestone of technical proposal, and even then not always at milestones corresponding to the serial number. This number is uploaded automatically, and it's easier to ensure its availability to the automated BOM. Secondly, isn't mandatory for the cost engineer, but sometimes such information may be required by related departments. For example, the buyer's service. Criterion 21. Indication of the supplier and the action plan for the supplier activities. In terms of describing the action plan for this supplier, we risk going into an area that is somewhat related but different from the one considered in today's case, namely the area of activity of buyer's specialist, in particular the indicators of price reduction for the supplier on which the buyer's KPIs, the timing of the NDA, the timing of the contract, and the start may depend supplies, terms of delivery, and etc. In general, I would like to note the following in this context. Firstly, this is a funny pun related to the translation as a term action plan, i.e., in turns out of the Russian-speaking management, the action plan is a tool for planning and monitoring the implementation of the plans. Secondly, more, the activities for procurement specialist or buyer in the context of design-to-cost management methodology based on the value analysis we'll discuss in detail in issue number 18, Commercial Negotiations in the context of the design-to-cost methodology. Criterion 22. Specifying the nomination status of the company and supplier. The company and supplier nomination status usually looks like nominated, not nominated. The name of the supplier is indicated in the next column, and the date of nomination and protocol number can also be indicated. Criterion 23. Specifying the responsible buyer. In the responsible buyer column, the necessary contact detailed in the procurement specialist in charge of that area are indicated. Criterion 24. indication of the actual direct cost for component prices of the purchase part from the technical commercial proposal and the date of commercial proposal. This BOM block indicates the price of the component either in accordance with the latest commercial offer received from the supplier or an expert assessment of the current price of the component, for example, based on benchmarking data, expert calculations, and etc. Criterion 25. Indication of one-time costs, tooling, R&D, and the date of the commercial proposal. Specifying one-time costs, i.e. costs for research and development, testing, and tooling, make, in contrast to the previous criterion we discussed. On the contrary, it's prerogative of the cost engineer at the stage of formation of the BOM, at the stage of pre-design and pre-design engineering documentation, since the production equipment for prototypes and for mass-produced products is different in most cases. The cost structure of the equipment can consist of two components, the cost of prototype and serial equipment. If we talk about practical examples, then we can consider the example of stamping a sheet part. Prototype tooling stamp, as a rule, is made from aluminum alloy and has a insignificant resource, about 500 to 1000 strokes. In addition, aluminum tooling can be modified for relatively little money in accordance with the changes in details during the design engineering documentation modification at the stages of the preliminary and technical design engineering. Stamping tooling for mass-produced products has a significantly longer service life. Depending on the series, it's made of steel. Criterion 26. Indication of the forecast, direct costs of prices, and corresponding deviation. In this case, we are talking about the forecast prices for control periods, and weighted average deviation from target and current values are indicated only the BOM at the stage of serial design engineering documentation and automated BOM. Since the main reason for the need to generate a forecast is changes in exchange rates, changes in market prices for raw materials, and etc. Macroeconomic factors that, as a rule, are not taken into account when forming a BOM at the stage of the pre-project and project design engineering documentation. In fact, we are talking about the price forecast over the time horizon of a month, or quarter, or half year. In the example of BOMs, the stage of serial design engineering documentation, which we will consider below, such columns will be omitted in the order not to make the file too bulky. The availability of information corresponding to this comparison criteria is optional. Therefore, an asterisk is placed in the table of the slides indicating value for reference. Criterion 27. Using a single assessment currency. The criterion shows that a slight change to the exchange rate at the stage of the project is not critical in terms of the significant error of the pricing methods used, i.e. parametric methods for estimating direct costs simply absorb this minor fluctuation in the exchange rate. Therefore, to simplify the calculation, you can use a single currency. An example of this approach is the basic project calculation. BOM is a stage of pre-design and project design engineering documentation. Despite the proximity of calculations, they are still performed using different currencies. Since in it, unlike the basic calculation, there are references to technical commercial proposal in which the currency may be different. And criterion 28 specifying the currency from the technical commercial proposal, the base currently and its current exchange rate. The logic of using this criterion is the analysis correspond to the one described in the previous criterion, namely the milestones of the project corresponding to the development of serial design engineering documentation, i.e. the formation of a BOM at the stage of serial design engineering documentation or automated BOM. The calculation accuracy is already compatible to currency fluctuations. In the practical work of a classical cost engineer, generally speaking, there is quite little time to take a critical look at the classical BOM, not modular as in our case, and try to make sense of it in any way other than in practical plane. For example, ask the following sequence of questions. The first: Can the BOM be considered an upper-level calculation? Yes, because it has a simplified design engineering structure of the product and the corresponding current places from a technical commercial proposal. The second, can the BOM be considered a purchasing or buyer's specialist tool? Yes, because it has a vendor nomination statuses and an action plan. The third, can the BOM be considered as a project management tool? Yes, it seems that yes, because since the data it's given in a context of the milestones of the project. I believe that after analyzing the comparative table of the basic design and aggregate calculations of two types, none of the listeners had any doubts that within the framework of the design to cost methodology based on the value analysis, BOM isn't just a calculation. As it's positioned on the slide, applicability of pricing methods of the context of milestones of design engineering documentation according to GOST 2.103. Yes, there are calculation elements in it, so we will not exclude it from the classification of applicability, but we will try to define BOM in the context of the criteria discussed above for comparisons with the basic project calculation, or BPC. Let's try to formulate the definition of bill of material in the context of pricing as well as in various contexts of working groups project activities. In terms of the term calculation and pricing, BOM can have a following definition. BOM is a top-level calculation of direct costs for components formed using the methodology of aggregate pricing, the degree of abstraction of which depends on the current milestones of the projects. It sounds modest, but it's what it is. In terms of the professional skills of the specialist of the cost engineering department responsible for maintaining the BOM. BOM is a representation or cast of the current milestone of the project. In terms of the required competencies of the team of cost engineering specialists, for the pre-project stage and the project design engineering stage, the early stage cost engineers mentioned above are required, who have skills in parametric pricing techniques, as well as knowledge in related fields, design engineering, production technology, industrial design, marketing, quality management, etc., i.e. areas of corresponding to the composition of the project's working group, which make it possible to carry out an expert assessment of direct cost in condition of a small amount of initial data. Serial design engineering milestones require specialists who have classified as serial milestones cost engineers who have a slightly different professional profile, namely those with skills in working with ERP and PDM systems of analytics of large amounts of data management, and big data specialists. In terms of procurement of buyers' activities, BOM is a display of the current project milestone in terms of the top-level list of purchase parts, the status of the supplier's nomination, the supplier action plan, deviation from the target price of purchase parts, and the forecast of price changes for purchase part. In terms of industrial design and engineering activities, design engineering activities. BOM is a reflection of the current milestone of the project in terms of the potential to reduce direct costs of product components and bring them in line with the target by making design changes to the product. Let's consider a practical example of direct cost calculation formed by the aggregate method in a universal modular format that meets the requirements of BOM as a stage of pre-design and project design engineering documentation, and BOM as a stage of serial engineering design documentation. Serial design. For the signboard 25 drone in the context of the comparison criteria listed above. Criterion 1, 2, and 3, general, conditional, universal in terms of their applicability to attribute models. Let me remind you that the main role of introducing these criteria is firstly the separation of the classical BOM and BOM within the framework of design to cost management system based on the value analysis, and secondly, within the framework of these criteria for comparing project and serial calculations, we access the degree of automation of the BOM and the presence of a division of responsibility for filling the profile BOM blocks. There is no comment on the practical assessors of the BOM within the framework of these criteria because, generally speaking, it's difficult to add anything in addition to the above. The first and main functional model of BOM is the BOM cost engineer attributes model. The peculiarity of this book is that the cost engineer is responsible for completing this module, and the main target user using in their activities is the project manager. However, the project manager can use the rest of the BOM models in his activities, which will be shown below. Looking ahead a bit of the list of criteria, we know that in accordance with the formulation of criterion 11, this module includes not only the BOM operating field with direct costs, but also the full structure of the drone sales price, borrowed from the basic design calculation, which is located below the main BOM field. The reasons why the full price structure of the product is missing is some BOM variants formed by the aggregate methods have already been stated above. The first column of this module is named Signboard 25 structural model, and together with the subsequent blocks of columns corresponding to the name of the milestones and borrowed from the basic project calculations, or BPC. The right of the structural model of the field borrowed from the basic calculation, we see the make or buy column criterion 4. We have already considered the logic of filling in at least issue number 8 or practical case number 2. With regard to the case under consideration with the signboard 25 drone, according to criterion 4, make or buy criterion, based on the analysis of the BOM block, the project manager or another user can conclude that the manufacturing company carries out only the final assembly of the product and all components come from external suppliers, which can be conditionally divided suppliers or mechanical parts, fuselage elements, suppliers, or relatively simple electrical components, connectors, harnesses, and etc. Suppliers of relatively complex mass-produced purchase parts of well-known brands, electric motor, flight controller, radio transmitter, and digital video module. Consideration of the drone case in the context of criterion 5 formulated as an indication of approved target direct costs for the product or product components and reflected to the block called block for calculation analyzing target direct costs of the attributes model, cost engineering suddenly led me to the need, at the least indirect mention of the issue of transferring target prices to external and internal users, which generally speaking doesn't have an unambiguous answer that most top-level managers, cost engineers, and design engineers would agree with. Practice shows that each of the mentioned and not mentioned members of the project team makes this decision based on their own life experience. Within the framework of the terminology of the dialectical philosophical concept of the development, with the framework of unity and struggle of opposites in relation to the target prices, the following two statements can be formulated. The first statement: if the target price of the component is transferred to the supplier, there is a certain probability that the supplier will receive excess profits provided that the expert calculation of the target price was performed incorrectly, the effect of the inflated target price. The second statement: if the supplier doesn't transfer the target price of the component, there is certain probability that, based on the results of the development of the product on its component, we will receive either a component with a price significantly exceeding the target value, which will lead to a delay the project due to the need for a redesign deviation from the target profitability of the product, and other unpleasant things, or an excessively cheapened components that will not give our product an advantage over competitor's product, on the conditional unused stock at the target price. Personally, my point of view is that the target price at the pre-project of the project design engineering documentation stage still needs to be transferred to the both suppliers and design engineering developers, because the product of its price are only an intermediate stage of the investment product. In fact, the occurrence of situation which we make mistakes somewhere and will buy some of the product components at the target price, but above the market price, and at the same time all the product indicators will be fulfilled. This is an indicator of the successful implementation of the product development project and the good work of the project manager. In turn, the search for such components for which we conditionally overpaid, in my opinion, should be one of the key aspects of the work of specialists in the field of lean manufacturing, who will oversee the project as the milestones of mass production. The difficulty of deciding on transfer or non-transfer is further compounded by the fact that the target prices for components can be adjusted from milestone to milestone, especially in the pre-project and milestones of corresponding the development of the project design engineering documentation, which, generally speaking, we are most interested in. Closer to the milestones of the serial design engineering documentation, prices are already conditionally settled. But before that, in practice, situations arise that are unpleasant for the cost engineer when the target has charged during the transition of the milestones, and at one of the meetings, the specialist directly related to the need to achieve this target value of project management with a good memory for numbers, such as fortunately it happens. Maybe you should pay attention to this and ask for question for the category why do you have one target today and another tomorrow, etc. In general, the system of the end-to-end project data, which includes the target price for purchased parts and direct cost targets, generally helps to avoid such situations. Nevertheless, such situations do occur periodically. In this regard, cost engineers prefer to minimally advertise their inner kitchen. For example, they try never to show the entire BOM, but only show fragments of it, try to do advertisements to the methodology for calculating the target, and etc. In my opinion, quite cheap techniques. One of the reasons for the dancing of targets in the components at early milestones is that different methods are used to calculate them in different milestones, which is our BOM. Unlike the conventional classic BOM has a rather cumbersome target calculation block. In the statement BOM is just a column without specifying for the methodology using which the target was calculated for you. In our not classical BOM, the project manager is provided firstly with information on the list of possible calculation methods, secondly the results of calculating target prices. The degree of block fitting in the list of methods used directly depends on the availability of initial data at the current milestone. Calculated using various methods. Secondly, in the column with approved the target is marked as a milestone, i.e. the BOM user understands that the target may change in another milestone. Thus, one of the indicators of the professional qualifications of the project team and the project managers in the context of cost engineering is an understanding of the moment when the target price for components have already been more or less established and can be transferred to suppliers and developers without the risk of the need of significant adjustments. The ideal case is a situation where, according to the results of development, we have some margin for deviations from target prices. But in practice, this situation rarely occurs, at least in projects where I happen to participate. To put it mildly, there was no margin, or rather there was, but negative. In this context, especially in the absence of a target reserve, the indicator of the degree of novelty begins to play a significant role, which was partly considered by us in the framework of the case number 2. It will only note that the actual mechanism for calculating the degree of novelty is somewhat more time-consuming than what was demonstrated in case number 2. In particular, we are talking about the need to use expert assessment methods, which are devoted to issue number 13, as well as a slightly larger among the intermediate calculations that have to be performed in practice. This concludes the analysis of the compliance of the cost engineering attribute model with criterion 5, and we will consider it in terms of the compliance with criteria 6 to 11. I suggest not listing these criteria, but simply performing a brief overview of the blocks and sub-blocks and columns of the cost engineering attribute model, and making sure that all of them are mentioned and therefore taken into account. To the right of the block borrowed from the basic project calculation, there are blocks called calculation and analysis of target costs, one-time product costs in accordance with the technical commercial proposal, and total potential for reducing costs and expected effects on life cycle. The first of which is a conditional summary table of the results of the cost engineering division, and the second, it contains a set of data from the BOM purchase attributes module, which however are also a function of the attribute design module. Speaking of the block calculation and analysis of target direct costs, we are in fact talking about the block for calculating and analyzing target direct costs, and its sub-block called list of methods used to calculate target direct costs by the cost engineering service, availability and type of calculation, and target direct cost values for a serial product. Let's look at the listed sub-blocks and their content in more detail. The list of methods used to calculate target direct cost by the cost engineering service or sub-block contains a list of methods that can be used by the cost engineering division to generate target direct cost depending on the project milestone and the corresponding amount of initial data, including data from suppliers and production sites. In this example, the ideal case is considered, so all the columns of the block are filled in, but in practice this situation is quite rare, not only because of the above-mentioned lack of initial data as a milestone, but also because the specialists of the cost engineering departments may not have the competence to use some of the methods, or for example, due to the right deadlines for conducting analysis and setting targets. Note the individual nuances of filling in this block. Firstly, for various target price calculation methods, the total value of direct costs isn't given for this block, but its approved value, in this case $222.44, is already given in the approved target value, the column of the target cost estimates for a serial product block, which we will consider below. The logic of this approach, I believe, is quite transparent. The presence of several target direct costs for a product will not add anything, but confusion to the BOM, since it will reduce its readability due to the ambiguity. In general, the block's list of methods used to calculate target prices by the cost engineering service is a kind of analysis of the buffer or sanitary zone for target prices of individual components, in which there may be values that are not quite adequate to reality, values related to the specifics of the methodology used to calculate target direct costs, which, however, do not. As a result, they will reflect it as the value of the approved target value column of the target direct cost values for a serial product block. Despite the fact that in our example we do not observe such significant fluctuations in practice, they sometimes occur, and one of the main duties of a cost engineer is to ensure that such outstanding values are analyzed. Secondly, the sub-block list of methods used to calculate target direct costs by the cost engineering service is a confirmation of the above statement that although BOM is a conditional visualization of the aggregate pricing method, it simultaneously contains ready-made data for calculating target direct costs performed by alternative methods. Thus, BOM, however, will not delve into this issue at the same time, and it will be discussed in more detail below, within the framework of the general conclusion of section 1.1. The availability and type of calculation subblock contains the prototype and serial product subblocks, which in turn contains the columns of the same name, calculation formed by expert evaluation and actual calculation. The meaning of the existence of the block is fully described on its name, namely in this block we simply show the status of the availability of one or another type of calculation for the current milestone. Speaking specifically about our case, we do not have actual calculations because that is we are all obviously either at the pre-design stage or at one of the milestones corresponding to the development of the design engineering documentation, i.e. at milestones preceding mass production. There are dashes for standard products and purchase parts, and this tells us the supplier refused to provide calculation. This often happens in practice. The target direct cost values for a serial product subblock contains the columns approved target value, absolute current deviation, and relative current deviation. In this example of filling in the BOM, the values of the approved target value column correspond to the values of the target direct cost calculated by the value analysis method given in the value analysis method columns of the list of methods used to calculate target direct cost by the cost engineered service block. Conditionally, we can assume that the cost engineer in this case considered that the values calculated by the value analysis methods are the most reliable for the current milestone of the project, i.e. the milestones where there are no actual calculations and we have to deal with targets determined using parametric methods which can include value analysis. A common mistake when filling in the approved target value column is to enter the arithmetic mean calculated on the list methods used to calculate target values by the cost engineering service book. This approach is not correct because it's a simplification that does not make into account either the magnitude of the standard deviation or other external design factors that are adjusted from milestone to milestone. See the availability of initial data, already mentioned above, the degree of reliability of calculation from suppliers, and etc. Comments on filling in the columns absolute current deviation and relative current deviation are, in my opinion, unnecessary. The one-time product costs is in accordance with the R&D plan section indicates the data from the R&D plan and production equipment that are relevant at this milestone. The block total reduction potential of current direct costs and expected effects on life cycle summarize the expected effects of both design engineering and technological measures to reduce direct costs and commercial measures carried out by the buyer. In other words, from expected results of commercial negotiations with suppliers. Regarding the functional purpose of the total direct cost reduction potential block, everything is also simple. When the project manager opens the BOM, he can access the prospects of reducing one-time costs and direct costs of R&D, tooling, and product components respectively for the current project milestone. How exactly this book is formed, or rather, what makes up the expected reduction in one-time and direct product costs, we will consider as part of review of the following BOM modules. A necessary attribute of this block is the volume of production as a life cycle, i.e., the parameter included in the basic list of initial data for analysis, the standard form of which we considered at the very beginning of practical case number 2 at our training course. I do not see any point of commenting on the effects of one-time costs. I only say that in terms of R&D, they are mainly based on the results of reassessment of the standards of dependent labor intensity, as well as the degree of novelty of the product previously considered by us in practical case number 2. The Signboard 25 drone, generally speaking, turned out to be a fairly successful example for a point of view of visualizing the effect of a slight of a new cents or a couple of dollars reduction in the practice of individual components based on the results of design, technological and commercial activities, and the effects obtained in the case of large-scale production. Indeed, it turns out that with a production volume of 1 million units, and the manufacturers save about 11 million over the life cycle, and this without taking into account the increased marginality that he will have when selling consumables, which, as we saw in the issue dedicated of the use of the value analysis tools by a review blogger, is definitely the case. The amount may not look very impressive against the background of the each flows of a large company, but from the point of view of the layman, it looks, generally speaking, quite solid. The second functional model of the BOM is the BOM design attributes model, design engineering attributes model, which is the responsibility of design engineer. According to criteria 12, 13, and 14, the conditions are met. The upper of the middle level components are listed in the product structure in separate position, while the low level components are not listed separately but as one generalizing combined position in the structure called fasteners and components and connectors accordingly. If in this case we were not dealing with BOM at the stage of pre-project and project design engineering documentation, and with BOM at the stage of serial engineering documentation, these positions would be detailed and presented in the form of an actual list of fasteners. For example, for this drone, DIN 912 type screws with an internal hexagon diameter from the 1.5 to 2.5 of various lathe are mainly used in the fuselage. As a result, all components of the project structure must be decomposed within the framework of the BOM at the stage of serial engineering documentation, except for those with part indicated in the format attributes block in the type column. According to criterion 15, it can be added that the principle of decomposition into several separate file steps is shown on the screen of the Signboard 25 drone BOM. It was not used simply because relatively simple from the constructive point of view. Object of analysis was specially chosen for the training case, and there is simply no need to perform decomposition, i.e. the description of all components is placed no one tap of the tabular editor without making it excessively cumbersome and inconvenient to edit. If we were considered a drone weighted several hundred kilograms of several tons with an appropriate list of systems and assemblies, then such a need might arise, and we would have a situation with separate BOMs on separate tapes on separate files for each of the upper level units and systems. According to criterion 16, we note that the BOM shown on the screen describes only one version of the Signboard 25 drone, which is indicated by the code CBT25 in the execution column, which is quite accessible and sufficient for a training case. If you were considering two versions simultaneously, Signboard 25 and Signboard 25S, that it would be necessary to enter at least one more line for a power plant, and therefore it would be necessary to enter addition executional code. The execution column, for example, CBT25S, duplicate with matching lines and the new code. Then using the filter function, if you can create in the tabular editor, you can create a BOM with two different versions. Perhaps in the era of automation and big data, this approach looks a bit funny, but the early milestones of a project everything often looks like this. Criteria 17, 18, and 19 relate to the evaluation of design attributes, formal quantitative and qualitative, respectively. The module BOM design attributes model, in this case, is located to the right of the BOM cost engineer attributes model. In general, the location of the modules in the BOM isn't important and is selected depending on the milestones of the project and the availability of information in the blocks. In BOM, compliance with this criteria is displayed to the BOM design attributes module, and 3 sub-blocks corresponding in name to criteria 5, 6, and 7. The BOM design attributes module consists of 2 main blocks: basic design attributes and plan of design and technological measures to reduce direct costs only for a serial product. The basic design attributes block in turn consists of sub-blocks: formal attributes, quantitative and qualitative attributes. And the formal attributes sub-blocked, we see design engineering designation of drawings of 3D models for aggregates and system, the name of the design group, as well as the type of components of the product structure. In this case, it's an assembly unit, purchase products, and standard products. The names fully correspond to the name of the specification sections of the United System of Design documentation, which facilitates the process of filling in this bill of material block. In the quantitative attributes sub-block, we see columns named quantity, units, weight and dimension, length, weight, and height. The information of fulfilling of these sub-blocks is present from the United System of Design documentation specification document. In addition, it's present to the standard format of the structural model used in the value analysis and reviewed by us in the issues of the drone review with the value analysis method WOOP 2.5 inches and other issues within the framework of which the formation of structural and functional models was carried out. In the qualitative attributes sub-block, options for the use of various structural materials and their corresponding technological processes are presented. This separation is due to the fact that it's a milestone of the project corresponding to the design engineering documentation that prototypes are manufactured using the appropriate prototype technologies, which differ significantly from the serial ones. That's why for the prototype parts of the fuselage elements, the ASA, PTG, and HIPS materials used in the 3D printing technology and carbon fiber sheet, fasteners, ABS or polypropylene granules produced by machining and injection molding, respectively, are simultaneously indicated in the BOM design attributes block. The next block of this BOM module is called Plan of Design Technological Measures to reduce direct costs, serial products only, and contains a number of basic reference sub-blocks. The main sub-block of this block includes list of measures and potential effects of the event, cost reduction containing respectively a list of measures to reduce R&D costs, production equipment, and product components. The potential effect of these measures is calculated in this first approximation based on the production volume of 1 million units. Respectively, when assessing the possible effects, the number of units of components in the composition should be taken into account. For example, for battery mounting brackets, the effect for one bracket is shown. Therefore, 2 million are indicated in this production volume column. There are no effects for electric mufflers because these are purchased products, the design engineering structure of which we cannot make changes, etc. Generally speaking, the action plan is usually not included in the BOM. However, within the framework of the modular concept of the BOM, the events are directly related specifically to the BOM design module, i.e. the module for which the design engineer is responsible. The issue of sharing responsibility of filling in BOM blocks within the framework of the design to cost management methodology based on the value analysis has already been discussed above as part of the commentary to comparison criteria number 12, so we will not dwell on it. The only thing I would like to add is that the direct formulation of measures can be carried out both on a free format and within the framework of formal methods. For example, the methods of engineering brainstorming, the description of difference of which from classical brainstorming were considered by us is in the framework of issue number 13, or the methods of factor research or MFR, which was reviewed the framework of the issue number 9. The reference subblocks marked the asterisks of the block include costs, the implementation of activities or R&D or refinement, etc., adjustment of the budget of the one-time project block of project costs, and the total adjustment of project completion dates, weeks. These columns are filled in based on data from the suppliers of the listed services, for example, the manufacture or modification of already manufactured equipment or from an engineering center performing R&D. In fact, this happens as follows. The project manager approves a proposal to amend the design and engineer documentation for the components, which sees a description of the change management design procedure, according to which, firstly, the design engineering documentation for the component is changed. Secondly, the design engineering documentation for the tooling is changed, and further changes are made to ready-made tooling, and all this is meters per second. It's a joke. To obviously takes time to implement all these innovations, which is displayed in the column total adjustment of project completion dates, weeks. Usually, in such cases, weeks are used as time measurement units, also norm hours are still indicated in work calculations. The convenience of measuring in weeks, as many have already guessed, is due to the fact that the framework of project activities, including international practice weeks, are used when planning work. Let's note an important nuance of the project manager's perception of the information from this subunit of the design engineering module, which is most conveniently formulated in the form of the question-answer. Question: what does the total time adjustment of 16.5 weeks mean? Answer: this means that the total labor intensity of the project has increased by 16.5 weeks due to changes in design engineering documentation, but this doesn't mean that the project implementation days have shifted by 16.5 weeks to the right, since the listed works can be performed in parallel. i.e., there will be a shift to the right, but they're likely to be less 16.5 weeks. In terms of filling out the responsible section of the design attributes block, I think detailed comments is not required. We just note that in cost engineering attributes and procurement attributes block, there is only the responsible person we are talking about, the cost engineer and then the buyer, respectively, and in the design attributes block, responsible to design engineer and technologist. The fact is that the discussing the list of complexity of work on the design, manufacture, and refinement of equipment, and as a result, in discussing its economic characteristics, it's usually the production organization technologist, a specialist in the production engineering department, who takes part, and not the designer and technologist of the design bureau. The area of responsibility of the designer, we do not consider the role of the design bureau technologist for simplification of thought. He actually participates in the development of the component, accordingly includes the complexity of the development of R&D of the product component, and as well as its design and manufacturing technology. The degree of detail of filling the BOM design attribute model for the BOM at the stage of serial design engineering documentation is similar to that shown on the screen and looks the same, with the only difference being that it can pattern the field and automatically and has more lines in the structure. At this point, the review of the BOM design attribute models can be considered complete in the first approximation. Let's move on to the next module, namely the BOM purchasing attributes model. The purchasing specialist is responsible for completing this module, as the students probably already guessed. With regard to specifying the name of the supplier and the action plan, the status of the nomination, and the responsible buyer mentioned in the comparison criteria 21, 22, and 23. First of all, we know that the degree of completion of the procurement module or buyer's module, as well as the design engineering module, directly depends on the current milestone of the project. Classification of the incoming sum blocks of BOM purchasing attributes model, it differs from the BOM design attributes model and includes two large sub-blocks. First, basic buyer's attributes, and the second, a plan of buyers or commercial activities to reduce direct product cost only for mass products. The basic purchasing attributes block, in turn, containing the following sub-blocks: formal inventory attributes of company, search and list status, RFI, RFQ, and RFP, supplier's name and date of receipt of the technical commercial proposal for services or components, and the status of date and service component supplier nomination. Let's look at the listed sub-blocks in more detail. The formal inventory attributes of component sub-block contains three columns: inventory items number, inventory items name, and inventory items type. The inventory numbers used in the procurement management system and mentioned in the formulation of criterion 20 are not required in the BOM at the stage of the pre-project and project design engineering documentation. However, I put them down simply to improve the quality of the BOM visualization in this tutorial. Accordingly, in the case of filling in the BOM at the serial design engineering documentation stage, filling in the inventory item number column in most cases is firstly automated, and secondly it's highly desirable. The inventory item number is assigned in the internal accounting system of the procurement service in accordance with the business process in force in the company, which doesn't relate to the scope of our review. For a cost engineer or project manager, the inventory item number may be needed for a local task, but in general it's present in the BOM with the status for reference. According to the inventory item name parameter, the situation is similar to the items number. The availability of this information is desirable, but not necessary. As the pre-project and technical proposal milestones, two of these columns are likely to be empty, but as we approach the milestones corresponding to the development of the serial design engineering documentation, and even more so in the conditional automated BOM at the stage of the serial design engineering documentation, these columns will be filled in. In the inventory items type, columns will note the following. In fact, it's possible to list a fairly large list of types of goods and services, namely goods for sale or finished products, raw materials, materials components, purchase parts, packaging materials, goods in circulation, consumables, fixed assets, goods for sale. The fact is that, firstly, most of them will be taken into account in the full structure of the selling price, i.e. below the main direct cost fields or the main BOM field, in our case below the line fasteners kit, and secondly, use us as cost engineer, especially at milestones. Generally speaking, most of the listed types of goods and equipment are not particularly interesting due to the size of the calculation error. Due to the above reasons, within the framework of the purchasing attributes block, we will reduce the list of types of goods and services to 4. First, components, joint venture. Second, components of purchase parts. Third, standard products. And fourth is materials. The following three sub-blocks, namely search and list status, RFI, RFQ, RFP, And suppliers name and the date of the receipt of technical commercial proposal for services components, and status and date of service component supplier nomination can be directly attributed to the product manager's toolkit within the framework of the procurement module. Therefore, we will focus on them and analyze in more detail. The search and list status RFI RFQ RFP block contains information about the number of RFIs RFQ RFP sent, i.e. three values separated by arrows, indicating the sequence of the information, which we see in this block, is nothing more than a conditional indicator of the amount of work performed by the buyer in this area. Thus, by simply looking at the content of this block, the project manager can already estimate the volume and effectiveness of the work performed by the procurement specialist. I will not delve into the meaning of the terms RFI, RFQ, RFP in this case. Listeners can find a transcript, description, and list of the differences between these three procurement specialist tools freely available. In my opinion, it's also no point in explaining the downward trend of these values, since its presence is quite expected for any person who are schoolboy or student distributes advertisements. The block supplier's name and date of receipt of technical commercial proposal for service or components contains a list of supplier names for components listed in the BOM, as well as the dates of delivery of the components corresponding to the project schedule. The suppliers of the component for the prototype and for several products are different in some cases. Therefore, the delivery time for the prototype and the serial sample will be different in any case, so, as in the case of RFI, RFQ, and RFP, you need to fill in the data for both the prototype and the serial product. For the block status and the date of service components supplier nomination meets criterion 22, additional comments are not required. I believe the logic of filling is similar to the logic for the two previous blocks. The block A plan of buyers, commercial activities to reduce direct product cost only for a mass-produced product meets criterion 21. Is essentially filled out the same way as the block plan of design technological measures to reduce direct costs only for a serial product, which was reviewed by us in the BOM design attributes model, except that the BOM purchasing attributes model doesn't contain the cost of implementing measures subblock, which takes into account the cost of conducting the change management procedure. Simply put, the cost of conducting additional procurement activities in the form of commercial negotiations are not included in the BOM, otherwise filling out the block is the same. Compliance with criteria 24 and 25, namely indication of the actual direct cost for the component prices of the purchase part from the technical commercial proposal and the date of technical commercial proposal, indication of one-time costs, tooling and R&D, and the date of technical commercial proposal are provided simultaneously by three models, in particular the availability of technical commercial proposal, as well as the list of effects of procurement measures to reduce costs in the BOM purchasing attributes model, design measures to reduce costs, as well as the released effects in the BOM design attributes model, and the prices of components themselves, one-time costs, and the total effect of the cost reduction measures and the BOM cost engineering attributes module. Displaying projected direct costs for several months ahead, criterion 26, isn't presented in this BOM and will not be considered by us, including due to the fact that a comment on this issue has already been given above as part of a general overview of the comparison criteria. In addition, criterion 26 refers to conditional reference criteria. See the star on the slide with a list of criteria. However, if one of the students is interested in this BOM block, then it can be provided as part of the training course on an individual basis. Regarding the compliance of the BOM with the requirements of criterion 27 and 28, I believe no additional comments are required in this case. Depending on the requirements of the project manager, the degree of complexity of the product, and the current milestone of the project, both a single currency BOM, in this case the main currency is a dollar, in this case, and a multi-currency BOM can be formed, with all corresponding advantages and disadvantages in the form of the need for manual updating the exchange rate for automated BOM executed in a tabular editor. Let's formulate general conclusions on section 1.1. So, the BOM within the framework of the design-to-cost methodology based on the value analysis isn't just a top-level calculation of product costs, containing a number of additional reference data and logically related to the area of responsibility of the cost engineering department, as it may seem at first glance, and as it implemented within the framework of the activity, the classic division of cost engineering. See issue number 2 of our training course. BOM within the framework of the design-to-cost methodology based on the value analysis is a project management tool with a modular structure, models of cost engineering, design engineering, industrial design, and procurement of buying attributes, and is derived from the following factors of project management. The first, end-to-end project data, or EPD, in particular, structural model and target values of the direct costs for product components. The second, a set of structured technical and unstructured data from various specialized areas of the working group participant, in accordance with a list of specialized attribute models included in the BOM. And the third, a set of requirements for accounting and reference documentation used in project management and formed in the process of making managerial decisions as the milestones of the project. In addition, we note that earlier we considered the BOM in two guises. Firstly, as a tool for formalizing the aggregate pricing method, and secondly, as a specialized tool for the project manager designed to manage the direct product costs and, as a result, the selling price at a fixed margin. The presence of the BOM cost engineering attributes model, a block of calculating target costs, allows to assert the existence of a third hypostasis, namely BOM as a practical project management tool within which information about target values of direct costs is consolidated, calculated using various methods. In addition, it's within the framework of considering the target cost calculation block that we encounter the conditional dualism of the applicability of pricing methods in cost engineering. First is the formation of the current value of direct costs and the selling price as the milestones, and secondly, the formation of the target price of the component as a milestone. We're talking about the pricing methods in cost engineering, which once again underlines the importance of this issue. The list of control parameters is listed within the attribute models discussed above and includes the status of component development, the status of supplier nomination, the formation of periodic reporting control sections, estimates of the deviation from the target cost of the product, and so on. Consequently, the BOM is an independent practical tool that doesn't relate to conditional primarily initial data. Therefore, its inclusion in the list of EPDs, in my opinion, doesn't make sense, which is in general doesn't detract from the practical significance of the BOM. Let us formulate specific conclusions on section 1.1. Private conclusions in this case mean conclusion about a change not only in the structural format of BOM as part of the application of the design-to-cost methodology compared with the structural format BOM used in classical cost engineering, bringing it to a block structure containing relevant profile attributes, but also a change on the overall positioning of this by transferring it from the area of responsibility of the cost engineering department to a higher and more general level in the project hierarchy named to the area of responsibility of the project manager. In fairness, it worth noting that a significant part of the content of the specialized attribute blocks is present in the conventional classic BOM. However, it's far from the volume that the modular BOM contain. For example, in the classic BOM, I didn't see such design attributes as a group name, dimensions, structural materials, and technological process, whereas this information is often necessary for a cost engineer to conduct an analysis. In addition, the modular structure of the BOM allows you to implement, first, the distribution of the responsibility among the members of the working group for filling out the BOM profile block of attributes, an empty of insufficiently detailed BOM profile block for the current milestones of the project, is obviously a signal of the project manager, for example, that one of the members of the working group may be messing up, and etc. Secondly, compliance with the concept at the list of applicability matrices, the matrix of cost engineer, designer engineer matrix, industrial engineer, and project manager matrix, which is a system-forming concept within the framework of the design-to-cost methodology based on the value analysis. We didn't mention the marketer's matrix in this case because the main stage of marketing research still falls exclusively on the pre-project, which, as we remember, was the reason that the marketer applicability matrix wasn't performed in the context of project milestones with the rest of the working group participants, but in the context of the formation of a marketing plan. The section 1.2, the expert calculation method. The essence of the expert calculation is that it considers specific standards for the consumption of materials, standards of the time of production operations, standards for the wages for a given region, depreciation rates, and etc. Defined and ideally also verified by relevant experts. Generally speaking, these indicators cannot yet be reliably known or the early milestones of the projects that we are interested in, since there is no complete design engineering documentation and technological maps of the manufacturing processes of these parts. Nevertheless, the method of expert calculation is used, among other things, to justify technical commercial proposal provided by suppliers. In general, the situation is sometimes similar to that described in the classic, and the cost engineer is forced to act like anyone who does not have reliable calculations, but who still needs to go. We will not consider a practical example of expert calculation on this issue. However, if any of the students of our training course couldn't have a need of such calculation, I will be happy to provide them with a set of examples of various standard formats that can be used of the practical activities of a cost engineer without additional refinement. Section 1.3. The unit price method, the method of complex technical and economic parameters, or CTEP method. Section 1.3.1. General description of the methods. Initially, I didn't plan to consider an example of a product calculation formed by the method of combined technical and economic parameters or unit price. For reasons previously mentioned in issue number 13 and the issue drone review with value analysis methods WOOP 2.5 inches, I admit that individual listeners do not have the opportunity to familiarize themselves with these issues urgently, so let me remind you what we're talking about. This calculation at first glance will look relatively simple, and in fact will be a calculation based on a set of proportions, i.e. if 1 gram of hypothetical drone frame costs 50 cents and this one weight the frame is 20 grams, then for hypothetical drone under development with a frame weighing 25 grams, the price will be $12.5. The simplicity of this calculation is initially captivating and is the reason for the conclusion about the absence of the need of visualization voiced above. However, haven't figured out exactly what the standard form the calculating take unit price methods will look like. In particular, the fact it must contain data from the wait list, or in the absence of a structural model, drop-down lists with various units of measurements, the specific characteristics of the analog of the previous generation as a product being developed, and therefore their structural model, and it's just an opportunity to recall mentions of empirical weight formulas, the effectiveness of which is generally quite controversial, and which I mentioned in the very first presentation of the cost engineer project. I felt a slight sense of nostalgia for the days gone by, and a desire to return once again to the topic of specific parameters analysis, which was perhaps undeservedly ignored in almost all the videos of the cost engineer training course. Another reason why you should definitely pay attention to this pricing method. It's fairly frequent use in real practice due to the banal simplicity. That is, I can't bring myself to call the first approximation of the calculation example with frames weighing 100 and 125 grams voiced above due to its inaccuracy. But generally speaking, in practice in high offices, such conclusions are sometimes voiced aloud, and with a very serious face, if you following the terminology proposed by Baron Münchhausen. In the book Value Analysis by Anatoly Danilovich Shermat and Anatoly Pavlovich Kovalyev, a number of engineering methods for estimating total cost are given, which adjusted for a known amount of marginal profitability, although they cannot be directly attributed to pricing methods based on the unit price of a unit of measurement. This method has a very specific applied formalization form, see slide. But they can, with a completely calm conscience, be attributed to a more abstract category of pricing methods based on the description of complex technical and economic parameters of the CTEP method, which I have combined in the table of methods into a single group with a unit price of the unit of measurement. What exactly we are talking about? On the first slide, we see the standard formula, which, with your permission, I will not comment on. In addition, the first slide shows the formula obtained using the method of forming correlation and regression models, the mechanism of formation of which, as I already mentioned in the review of pricing methods, in issue number 15, isn't personally known to me, since it relates more to field of applied mathematics and technology. However, cost engineer, after all, you should be aware of the existence of similar models for various processing methods, so that based on the change or complexity of machining parts on the machine in normal hours, evaluate one or another design engineering variant of the analyzed object. On the second slide, we see a comparison formula with a geometrically similar object, the initial data for which are the calculation of the cost on the basis analog and its technological description, prevailing manufacturing technologies. For the pricing method used on the unit price, it makes no sense to form a separate calculation form, since the method is firstly auxiliary and secondly has an extremely low degree of calculation accuracy. The isolated practical application of this method is usually practiced at the pre-project stage, starting from the technical proposal stage. This method is used as an auxiliary method for the formulation and coefficients used in the framework of the coefficient pricing methods. In the context of considering the unit price method, a few words should be said about the golden ratio rule for construction set out of the book mentioned above, the essence of which is that the costs for the main and auxiliary structural elements should be 62% and 38% respectively. The problem of practical application is that, generally speaking, it's quite difficult to divide the components of a product into the main and auxiliary arms within the framework of value analysis. However, options appear, and there is many as two. The first option is a functional classification based on the classification of functions, but not generally accepted in value analysis, namely proposed in the framework of our course, namely design to cost management techniques based on the value analysis. The fact is that the classification announced in the issue number 7, as I mentioned earlier, has one significant advantage over the standard classification of functions in value analysis. This advantage lies in the fact that the formulation proposed in it corresponds to the principles of technical assignment formation in accordance with the GOST 15016, which makes it easy to convert structural and functional model into a full-fledged technical assignment that can be used within the framework of the project. But the advantages of this classification do not end there, since the basic classification of functions into consumer and operational fully corresponds to the golden ratio rule described above, i.e., this rule can be applied even before the formation of a full-fledged design engineering documentation, right at the stage of formation of structural, functional model, and technical assignment, formed on the basis. In fact, it's possible to immediately apply this rule to the test technical assignment, even if it's formed by conditional classical design engineering method, i.e., without the preliminary formation of structural and functional model, or in text format. Accordingly, the second option for applying the golden ratio rule is to analyze the AQS diagram in the context of this method, i.e., conditional divide the components by the importance parameter R and compare the corresponding cost values. Section 1.4 Method of configuration. The essence of the bundling method on its consumer presentation, i.e., the presentation in which we all encountered it in a car dealership when buying a car, can be visualized by formula: price equal to a fixed configuration price and additional option price. In the process of interaction between the buyer and the seller, this formula is usually used without any justification and reference to the actual cost of the opinion, i.e., the buyer doesn't understand the real cost of the driver's glasses case, but doesn't have any opportunity to choose something other than to take or not to take this option at the offered price. Therefore, in the context of using the bundling methods by a cost engineer or marketer, both of the price of the fixed configuration to a greater extent and the price of an additional one option to a lesser extent, in the process of their assignment require at least minimal verification of the option price using more accurate pricing methods, such as the method expert calculation of the value analysis method. At the stage of mass production, the situation with the use of the bundling method, the cost engineering is greatly simplified, since the direct cost of both basic configuration and additional options can be taken from the ERP system, add the margin to them, and obtain the required components of the product price. At the same time, there are usually several fixed configurations. For example, in the automotive industry, standards, comfort, and luxury, and they can be expanded without much effort by introducing additional ones. The options are already in the dealer's showroom. In our case today, first of all, we are considering one fixed configuration, signboard 25, without extra options. Accordingly, the application of this formula is difficult. However, if we turn to the classic option lists, which we reviewed in issue number 15, the marketing concept of the product, the context of design to cost methodology, in which we considered two versions of the drone of standard and sport, you can at least understand which components were placed in the more expensive or sporty configuration and exactly how pricing is performed for two fixed configurations. In general, for those listeners who are interested in the structural and optional differences between the two configurations of the drone, I refer with a clear coincidence to issue number 15 posted on our channel. Secondly, the feature of using the configuration method for complete product decomposition and cost engineering is that each option has its own conditional price, in the structure, i.e. pricing has a slightly more complex form than within the framework of the formulas described above. Section 1.5, the scoring method. We will not consider pricing by the scoring method since this method is inherently similar to, or rather a special case of the methodology for determining the significance and importance and relevance used in the value analysis, i.e. the number of points of a component is actually an assessment of its significance, but not in relative, but in absolute score terms. The advantage of this method have ensured its fairly wide distribution. We are talking about intuitive clarity as well as the possibility of its use in regulatory document, the formulation of which it's important to have a fixed value in score for a specific type of products and its components, which will be later used within the industry to justify the formed prices of a justification. For example, the degree of localization of the product. The disadvantages of this method, I believe, are also quite obvious. In particular, it's necessary to form a proportion of recalculated score when changing the structure of the product, indicates in the regulatory document. Well, you cannot introduce new components into the structure because there are simply no score for them in the regulatory documents. Thus, in parallel, there is a need to assign the most unified and streamlined formulations to the aggregates and systems of the product so that they can be used to assign score to innovative components of the product. Thus, we are faced with an increasing risk of calculation error, with an increase in the degree of novelty of the product, in particular, the appearance of components in the product that do not fit into the existing score classification. In general, the scoring method is good only where the degree of novelty of the product changes very slowly. The consequence of these shortcomings is the additional cost of updating the regulatory documentation containing the scoring methodology in order to bring it in line with the current level of technical development in the industry in terms of level of accuracy. It also, as in the case of the methodology for assessing the significance or relevance in the value analysis, depends on the degree of abstraction of consideration. The initial data is also similar to the list of initial data used in the framework of value analysis pricing. Students who are interested in the practical aspects of the assessment can familiarize themselves with the 719 decree of the Ministry of Industry and Trade of Russian Federation, which is publicly available on the internet. There is no mention of the point-based pricing method, but there is a method for assessing for degree of localization, which is similar in nature, since in both cases of significance of individual components the product is estimated as a fixed number of scores. Part 1.6, the coefficient methods. 1.6.1, general description of the methods. The essence of the method is to adjust individual calculation item according to the coefficient assigned by a specialist of the expert group, which usually includes either specialists from the project's working group or the third-party involved experts. To begin with, it should be noted that the condition for applying the coefficient methods is the presence of a basic analog of the previous generation. So, with the permission of the audience, I will turn to the hypothetical analog, which we have already considered in the issue entitled Drawn Review with the Value Analysis Methods, WOOP 2.5 inch, dedicated to the subject of analysis and blogging, namely performed reviews and unpacking. Those who have already read this release remember the hypothetical analog of the previous generation called Signboard 24, which is actually discussed in the review of the coefficient pricing methods, respectively all data on the components on this conditional analog of the previous generation is also borrowed from the previous release. Part 1.6.2 Initial data. The set of initial data for the calculation using the coefficient method is generally similar to the initial data for the basic calculation, except that the results of the expert survey and standard survey forms are added to it. In this case, experts are not required to form an expert assessment in the sense in which we considered with an issue number 13 of the training course, i.e., in fact, to set the coefficients that will need to be provided to experts and then enter the data into the calculation form of the coefficient method presented on the screen. The upper part of the basic project calculation send the formal format of a general mailing by email, necessarily indicating the deadline, will do dwell as a standard form. At first glance, data processing experts advise during the filling process do not look laborious, but I still recommend meeting some time limit for all these tasks, since what seems simply and labor intensive to a cost engineer sometimes causes certain specialists either a number of unexpected questions or to desire to postpone filling. A survive form for as long as possible, for example, in the next life or something like that. Part 1.6.3 Calculation example and comment. The key features of the coefficient method is comparison with other pricing methods. The need to decide which part of the cost items in the calculation can be attributed to the expert's area of responsibility and which remains on the conscience of the cost engineer. Generally speaking, it's difficult to overestimate the importance of the decision, since experts in the field of design engineering, industrial design, or marketing, in 9 cases of 10, at the slightest deviation form then prefer to remind that they do not understand related fields and even superficially. I.e., for example, design engineers are reminded just in case they are not economists, industrial designers, that they are not technologists, and etc. Thus, within the framework of applying the coefficient method, it's important not to overload the expert with related concept. In addition, it should be borne in mind that a specified ratio of areas of responsibility varies from milestone to milestone. Actually, the calculation presented on the screen for the pre-projects and 3 milestones of the project documentation is an example of visualizing changes in this distribution. Let's look at the differences of the amount of expert assessment for the listed milestones of the project. So, in the pre-project, we will see that the pre-project milestone experts are required to set coefficients for the main components of the drone, fuselage, flight control, etc. They are provided with a form in which in direct cost and the mentioned components are already set, some of which are purchase parts, but this is not important in this case. As a technical proposal milestone, the degree of abstraction of consideration is reduced due to the fact that formation of the first approximation of the design documentation begins and slightly larger amount of work is required from experts. Since the fuselage is now presented in the form of 8 sum components for which adjusted coefficients also needed to be set. As a preliminary design milestone, we ask the experts to add a coefficient for the cost item material, i.e., in fact, that is what will be used during assembly and the technical project. Milestone experts also need to put down the cost increase coefficient for the wage fund item. As we can see, a significant part of the work on the formation of calculations using the coefficient method in any case remains with the cost engineer. In this case, I would not like to give a numerical relative estimate of the distribution as a percentage, since the cost of generating the initial data for different items are different. The only thing that can be argued is that the share of responsibility and labor intensity of a cost engineer is obviously greater than the share of an expert who needs to set coefficients without having to confirm them with analytical calculations or thought. In my practice, some experts approached this issue very responsibly and formed some analytics on their own initiative. However, this approach can be attributed rather to the exception rather than the rule. Part 1.6.4 Applicability at milestones. See the table on the slide. Part 1.6.5 Particular advantages and disadvantages. The advantages of this method include the ability to be used at the earliest milestones of the project. And the second, intuitive clarity of the methods for both the experts of the expert group and the project management. The disadvantages of this method include setting coefficients by experts of the expert group without the need for any justification other than professional experience, work experience, etc. Sometimes questionable criteria for assessing reliability. The second, high demands on the level of professionalism of the cost engineer and the expert group, in particular related to the need to separate areas of responsibility in the calculation. And the third, high labor intensity due to the need to conduct a survey among the members of the expert group. 1.6.6 Accuracy level. Law meets the requirements for the pre-project milestones. See the applicability table. Use for subsequent milestones isn't recommended. Section 1.7 Product Cost Management Soft plus AI method. In previous issues, in particular in issue number 15, I have already casually mentioned the general principle as well as the pros and cons of using product cost management software within the framework of the cost engineering division, so there is no point in dwelling on this now. The product cost management software interface in some cases is limited by the information of the full production cost of the product without the possibility of entering margin parameters. In general, this is the only additional limitation that comes to mind if you consider product cost management software not as an applied cost engineering tool but as a pricing tool. The cost calculation algorithms in project cost management software are obviously based on correlation and regression models for calculating the time of machining, assembly, and other technological operations, which we are considered as a part of the pricing method based on the unit price, the method of complex technical and economic parameters of the CTEP method. Regarding the use of AI technologies in the previous editions, see issues number 11 and 13. I have already mentioned the possibility of using them, for example, in the formulation of the functions as part of conditional parallel automated brainstorming. I have no actual experience of using the AI technologies as a pricing tool in the framework of cost engineering, so I suggest considering of this topic as one of the possible directions for further research. Section 1.8 Pricing method based on the value analysis data. In fact, the value analysis-based pricing methodology has already been considered by us in previous issues and more than once, and in fact represents the formation of the values of the target direct costs of the components in accordance with the distribution of significance. In this case, we are not talking about the classic AQS diagram, but only about one of its components, namely the relevance, which in turn is determined based on the logical significance indicator. Such a stripped-down approach is due to the fact that the mentioned milestone of the pre-project, it's rather strange to talk about the degree of satisfaction or quality of execution or of implementation, since there is not even a prototype. As milestones, a test, a prototype, and pre-production samples are available, and the AQS diagram can be built in full. I do not mention the use of such end-to-end project data in pricing, such as an analog table, since the product price structure presented in the analog table is essentially a simplified versions of the aggregate pricing method. Part 2. Marketing pricing methods. 2.1 Calculating the optimal product price. See Appendix M, Michael, to issue number 15. 2.1.1 General description of the method. The marketing method of calculating the optimal price of a product is described in sufficient detail in issue number 15 of Cost Engineering training course on marketing issues, so we will not dwell on its description today. Part 2.1.2 Initial data. the target value of profitability or ratio of profit to total cost, and the parameters of the retail margin or dealer's margin, marketplace margin, excise tax, and etc. The next, the value of the total cost of the products, of the parameters necessary for its calculation, target sales volume for the period, as well as the cost for the analyzed period taking into account one-time costs or variable product costs, the sum of fixed and one-time costs for the period. The next, the result of competitive analysis and pricing strategy, and the next, the last, an analysis of the perceived value of the product performed among other things using value analysis tools, as well as the target value in percent of the advantage over competitors in terms of the ratio, more value for the consumer for less money. On part 2.1.3, calculation example and comment. In the upper part of the standard form, we see a summary table consisting of a list of analyzed parameters, column analyzed parameter, 3 columns with price calculation options, price calculation based on target profitability, price calculation based on competitors' retail prices or competitive analysis, and price calculation based on perceived value or value analysis pricing and marketing. The rightmost column, components of the final retail price, contains the desired parameters, in particular selling price, highlighted in purple. In the case of $460, everything below table 0 is the auxiliary blocks necessary to fill out the summary table based on calculation, as well as marketing and economics inputs that we have already listed above. We will not consider the step-by-step mechanism for filling in this table, since if the analyst has a calculation file, this mechanism becomes intuitive, noting only the final sales price for 416 was calculated for the target profitability, taking into account the decision of the admissibility of exceeding the sales price values obtained by 2 alternative calculation methods, 458 and $432, as well as taking into account data on competitors' sales prices. Part 2.1.4, applicability on milestones. See the table of applicability on the slides above. Part 2.1.5, particular advantages and disadvantages. The advantages of this method include the relative simplicity of calculations, a low complexity of application, relatively low requirements for the qualification of a cost engineer, no need for automation of the ability to use a standard form in a tabular editor. There is a connection between the basic values, the economic parameters of the product used in cost engineering and marketing, even without the introduction of a design-to-cost management system based on the value analysis, i.e., in fact, we are not talking about end-to-end design data, but about the basic calculation parameters specified in the business plan, such as selling price and profitability. The full cost of the product isn't always indicated in the business plan, but it can also be attributed to the basic economic parameters of the product, without which, at least the first approximation, it's unlikely that the project will be realized. The disadvantages of this method include a significant amount of specific profile marketing initial data that the cost engineers will have to request from the marketer. The second, the need for raw data, which requires marketing research. And the third, applicability only the assembled products, since if used for individual systems and aggregates, we will not have at least initial data on competitors' prices for individual companies that are sold on the aftermarket are not of interest to us in this case, since they will obviously be inflated compared to the assembled products. Part 2.1.6, the accuracy level of the method. Low because meets the requirements for the pre-project milestones. See the applicability table. Use for subsequent milestones isn't recommended. Part 2.2, differential pricing. Applies to both marketing and market pricing at the same time. 2.1.2.1, General description of the method. The standard list of price differentiation can be carried out in accordance with the following principles. The principle of price discrimination by age, gender, social group, and etc. The principle of territorial division, the principle of application of the discount system, the principle of margin sales volume, and other principles. As part of the application of the differentiated pricing methodology, a mathematical model of the consumer is usually formed, which takes into account such parameters as the price of the product, the consumer's income, demographic and psychographic, behavioral categories, desires, needs and effects for the consumption of the product. In general, the list is almost identical to the consumer profile we discussed in issue number 15. Within the framework of the general application of the differentiated pricing methodology, the following stages can be distinguished. First, setting the principle of price differentiation either in accordance with the standard list of principles or in accordance with a newly developed principle. The second, performance segmentation of consumer in accordance with a given principle of differentiation. The third, distribution of the volume of product sales, the volume of product output for different segments. And the last fourth, setting product sales price for different segments. The use of such a technique makes it possible to implement a marketing strategy within the framework of which it will be ensured. First, the full realization of the product release. Secondly, the achievement of the planned revenue indicator for all segments equal to or exceeding the income corresponding to the sale of the entire volume of GOST and the market price. 2.2.2 Initial data. In terms of the initial data for forming the calculation in this case, everything is quite simple. They are completely identical to the list of initial data necessary for forming the basic calculation, with the only addition in the form of strategy for setting differentiated prices formed using the methodology described above. In fact, the Signboard 25 model in question has several designs that differ in engines and video transmission system. Respectively, the real case of segmentation will be somewhat more complicated, i.e. segments will be firstly more, and secondly, they will be formed based on at least two characteristics, geographical and technical. Will simply the case, first of all, so as not to generate calculations, i.e. not to generate calculations for multiple executions. The simplification will be that will be only one model, but we also have two segments attributes, commercial and geographical. Thus, in our case, there are four segments. Three commercial segments in different geographical regions in which we plan to make a profit, and different ones. The target audience in commercial segments may be, for example, commercial sports clubs or independent pilots of different ages, and one social segment without specifying a geographical reference, for example, or orphanages or similar institutions where there are no plans to make a profit. Let's assume the planned production volume of drones for a period 1 million units. Thus, in order not to unfound it, let's try to perform simple mathematical calculations describing the marketing strategy outlined above for the full realization of product output while simultaneously achieving the planned revenue for all segments equal to or existing the income corresponding to the sale of the entire volume of product output and market price. So, the planned revenue from sales in a conditional ideal world where VAT is the same in all countries, everything can be realized instantly and at one time, etc. is calculated as follows, assuming the dealers are independent, i.e. the calculations of sales revenue for the manufacturer is based on the selling price. Let me remind you that according to the basic calculation, the selling price is 429.87 and the profit margin is 8.8%. All other indicators, excise tax, dealer's margin, VAT, are considered constant. In our case, a similar revenue from sales will be achieved in a more complex way due to the floating amount of profits for different geographical segments. In fact, with this approach, we are faced with a situation where well-conducted marketing research allows us to accurately assess the current market situation, with the possibility of selling products in segment from 1 to 3 with a slightly inflated profit level. In the social segment number 4, we can afford to sell the product below full cost. In our case, in a socially significant in segment 4, we sell the product at a discounted selling price of 183.16 as the full cost of the product. 322.85. If the volume of sales in segment 4 decreases, the product can be transferred to the consumer for free as part of the charity events, etc. Part 2.2.3 Calculation example and comment. In general, we have already considered in sufficient detail what the pricing process for segmentation will look like from the point of view of a cost engineer who focuses on basic calculation, so I suggest not delving further into either the theory of the combined calculation for individual segments presented on the screen. The difference between the approach of a marketer and a cost engineer can be described in a first approximation as follows. A cost engineer examines the pricing process with a degree of detail corresponding to the calculation presented on the screen, marketer with a degree of detail corresponding to the slide of the list of the slides presented, plus a conditional marketing calculation, which we discussed above in the framework of the method price cost, calculating the optimal price of a product. 2.2.4 Applicability of milestones. See the table of applicability of the slides above. 2.2.5 Particular advantages and disadvantages. The advantages of this method include the ability to cover all existing market segments and increase the customer base accordingly by including new target groups. And the second, the possibility of commercially justified use the positioning tools through charity events. The disadvantages of this method includes: first, if there are conditional arbitrage of sales prices in different regions or target segments in the same geographical region, there is a risk of losing customers when the pricing policy changes. And the second, the possibility of uncontrolled flow of goods between segments and the associated risks, loss of profit, uncontrolled prices in the segment, etc. 2.2.6 Accuracy level. From medium to high, since the condition for using this method is the availability of at least relatively accurate calculated total cost of production. The use of pre-project at a milestone, especially for technically complex products with a high degree of novelty, carries significant risks associated with the unpredictable changes in the value of the total cost. I don't see the point in giving a practical example for section 2.3, which is devoted to the method pricing based on the brand value or perceived product value, which, because firstly, this method, generally speaking, applies both to marketing and market, and secondly, if I were to visualize the area of responsibility for this method, it would not be much different from the visualization for the differential pricing method. In terms of the general description of the method, it can be noted that the issue of pricing based on perceived value has already been partly addressed by us as part of a review of the basic marketing method called calculating the optimal price of a product. In particular, the lowest positioned auxiliary block contained the columns perceived value calculated from the value analysis database and the real value, as well as a column with the deviation of these values. Accordingly, consideration of such standard characteristics of this pricing method as initial data calculation example and commentary, particular advantages and disadvantages, and the level of accuracy also doesn't make much sense. In terms of cost plus by investment cost plus and market to cost by investment to cost pricing methods indicated on the slide describing the applicability of pricing methods under paragraphs 3 and 4 respectively, I generally have nothing to add to what has already been said in issue number 15 of our training course. The general algorithm for applying cost-based and market-based pricing techniques of the early milestones of project is inextricably linked to the use of the parametric pricing techniques discussed above, since it's impossible to determine the amount of direct costs for individual product components and for the product as a whole in any other way in conditions of a small amount of initial data. That's all for today. Apply the techniques of value analysis and cost engineering. Subscribe to the channel. All bye.